This is a recording of the solution to application question 18 in Chem Activity 1B about atomic mass. We're going to use the same equation that we used in the solution to question 17. And in this case, the average mass equals the fractional abundance of each isotope times its atomic mass summed over all the isotopes. So I'm going to write this out and then we'll talk about what's there. Okay, so let's see what's here. What I took from titanium-46 is its abundance, 8%, and I translated that into a fraction and multiplied it by the mass of titanium-46, of that particular isotope. I did the same thing for titanium-47, which had a 7.8% abundance for the mass of this isotope. At the most abundant isotope is titanium-48, which is 73.4, so that's represented here. And then this is titanium-49, and this is titanium-50. I'm now going to multiply each of these terms, and I'm going to write them below. Okay, so let's look at what I did here. This number here, 3.6726624, is the result of this product. The second one is the second line, the third one is the third line, etc. Notice we've got a number that's a little over 3, it's 3.67, 3.66, 2.69, 2.64. This one is 36.66. So the largest contributor to the average mass comes from the isotope that has the largest percent abundance, which makes sense. Now I'm going to take a little detour here for some sig fig work. In the product of this first term, this number has 3 significant figures, this has 5. So in the product, we can only have 3. So I'm going to underline in blue the 3 numbers which are not significant. If we do the same thing for the second term, this 0.0780 has 3 significant figures, this has 5. We always go with the one that has the least. And so the second term also can only have 3 significant figures, so I'm going to underline all but the 3.66. In the next term, 0.7340, that has 4 significant figures. This has 5, so our result can have 4. So I'm going to leave the 36.66 as significant and underline the 1.098. The last 2 terms are like the first 2. In other words, they're going to be limited to 3 significant digits. And so I'm going to just underline those. Now, what we notice is that that means that when we're adding these things together, we know to the hundredths place in the first term, the hundredths place in the second term, the hundredths place in the third term, the hundredths place in the fourth, and the hundredths place in the fifth. So when I add it together, that means I'm going to be able to know out to the hundredths place. So this is the number that I get when I plug everything into my calculator, because when I'm adding, I don't want to drop the insignificant digits. I just want to keep track of them. So these are all the digits. And remember, we decided that when we were adding it up, we could know out to the hundredths place. So that means I'm going to underline the rest of those digits as being insignificant, and that means my final answer, which will report only the significant digits, will be 47.87 AMU, and that doesn't look much like an 8. Now it kind of looks like an 8. And let's see if that makes sense. So the average mass of titanium is about almost 48, and the most abundant isotope, which is titanium-48, has a mass of almost 48. So that makes sense. It's going to be closest. The average mass is going to be closest to the one that is most abundant in most cases.